Vectors, Part 1. Vectors. Vectors are shown by drawing arrows. This is an example of a vector. Vectors give you information. They give you information about something's magnitude and or something's strength. It also tells you the direction. An example of something that is a vector is velocity. Velocity has a magnitude and it also has a direction. Now, what if we want to combine some vectors or add vectors? Well, I want to talk to you about combining or adding vectors that are in the same direction. So I have an example here. Let's say I have a 1 Newton force to the right or east. And let's say I also have a 2 Newton force. That would be twice as long in length for my arrow, still pointing to the right or east. And what is the total if I were to add these two vectors? These two vectors are in the same direction, so you simply just add them. And so 1 plus 2 is going to give me 3 newtons to the right, or an arrow 3 times the length of the 1 newton vector. Okay, now what about combining vectors in opposite directions? Okay, let me give you an example here. Example A. Let's say I have a 1 Newton force going to the right, and I have a 2 Newton force going to the left. Or we could say a 1 Newton force going east and a 2 Newton force going west. Well, these are in opposite direction, and if I assign direction as going to the right as a plus x, then my 1 Newton force will be positive and my 2 Newton force will be negative. So in essence, we will subtract them, or we could write it out as 1 Newton plus a negative 2 Newton, that negative meaning going left, and my answer comes out to be negative 1 Newton. Let's do another one. Let's say I have a negative 2 meters per second because we're going left, plus a 4 meters per second because we're going to go to the right. And what would be my total velocity here if I combine these? That would be equal to a positive 2 meters per second to the right, like so. So what about combining vectors at right angles? Well, first I want to talk about finding the magnitude, and then we'll talk about finding the direction. Let's start with a traditional XY coordinate axis here. So I have a plus x this way and a plus y this way. We can also call that at 0 degrees is along the plus x axis. Let's say we have someone that starts at the origin and they walk 3 meters east or 3 meters along the horizontal axis or 3 meters at 0 degrees. And let me write 3 meters here. this person also walks 4 meters north or 4 meters in the plus y direction. Let's see here. And what is the resultant displacement, my blue line, of the person if they walk 3 meters east and then 4 meters north? What is that resultant or R displacement? Also, what is the direction? We'll do that in a moment, but I'm going to call that theta for later. What is the direction of that person? Now, hopefully you can see this triangle that I have drawn is a right triangle. Now, first what we're going to do is we're going to find the total displacement of this person, or we're going to find the resultant vector, also called the resultant vector, also called the magnitude of this person's total displacement. So in finding magnitude, or R, what we're going to do is we're going to use the Pythagorean theorem. And in finding the Pythagorean theorem to find the hypotenuse of this right triangle, or R, we're going to square what I have on the x-axis, plus I'm going to square what we have on, for the 4 meters, what's going vertical, and that's going to be equal to the square of my hypotenuse, or the resultant. Now to find the total resultant, we're just going to take the square root of both sides, and in doing so, I will get an answer of plus or minus 5 meters is equal to R. Now for the magnitude, I'm not interested in the plus or the minus. The plus or minus talks about direction somewhat, but we're going to find direction another way. So I'm actually interested in the absolute value here of this answer. So my resultant then is just 5 meters. That is the total displacement someone walks, the total change in position, if they walk 3 meters east and then 4 meters north. How about this person's direction? Well, we know they've had a total change in position of 5 meters, but in what direction? So what we're going to try and find here is theta in the above triangle. And in order to find theta, we're going to use a little bit of trigonometry. Now, if I were to take the 4 meter value, and that's the value on the vertical drawing, and divide that by the 3 meters, the horizontal part of the triangle, that would be equal to tangent theta from your trigonometry. And since I'm interested in finding theta, what I'm going to do is find the inverse of my theta. And the way we write that is my theta, or my angle, is equal to something called an inverse tangent of the 4 meters over 3 meters. And when you plug that into your calculator, you'll probably, if you have a scientific calculator, you'll have a tangent function. You'll need to press the second and then the tangent to get your inverse tangent value. Also, make sure your calculator is in degrees. In my calculator, I have to actually take 4 meters, then divide by 3 meters, get my answer, and then press inverse tangent. And I got an answer of 53.1 degrees. Now that's my direction, 53.1 degrees. Now that's almost the complete answer for direction, except for that's 53.1 degrees in terms of what? Well, that's in terms of my drawing. So when you look at my drawing, we could say that's 53.1 degrees above the horizontal, or above the 0 degrees in my drawing. Or if we're talking about north, south, east, west, we would say that's 53.1 degrees north of east. Another example of combining vectors at right angles, again we have our coordinate axis here, plus x plus y. This is at 0 degrees or east. This is north, south, over here is west. Okay, so let's say I have someone walking displacement of 1 meter to the east. Then they walk 2 meters north, 2 meters, and then they walk 3 meters east. What is their total displacement? In drawing this picture here, the total displacement, we're going to start from the tail of the first vector and combine that to the head of the last vector. And so the change in position looks like this, the blue line. But it's hard to tell how I'm going to use the Pythagorean theorems here. So what I would like to do is redraw this graph. 0 degrees plus y plus x, or east, north. Okay, and what I'm going to do is I can move my vectors around as long as they stay in the same direction. So I'm going to rewrite my 1 meter vector here to the east, and then I'm going to move my 3 meter vector down here. As long as it's going east, I can do that. And then I'm going to move my 2 meter vector north, and I can do that. And now I have something that looks like, ooh, if I put a hypotenuse in here, we might just have a right triangle. So my hypotenuse will be from the tail of my first vector to the head of the last, and here it is. Now, can we find the resultant in this diagram? I think we can. And so in finding the resultant, we're going to use the Pythagorean theorem. Let's combine on the horizontal axis where you have the 1 meter and the 3 meter. They're going in the same direction, so that total value will just be 4 meters on my horizontal side of the triangle. So in doing the Pythagorean theorem, r will be the absolute value of the square root of 4 meters squared plus 2 meters squared, and that answer comes out to be 4.47 meters. This is my magnitude in this particular example. So we'll say R is equal to 4.47 meters, and we'll put a box around that. For my direction, or my theta, do I have theta drawn in the picture? Let me double check here. Let's draw that in so we know where theta is. There's theta. For theta, I'm going to use the inverse tangent of 2 meters over 4 meters in this case. And that equals 26.6 degrees. So the person has a total displacement of 4.47 meters in a direction of 26.6 degrees above the horizontal, above the 0 degrees in the drawing, or 26.6 degrees north of east. The last thing I want to talk about in this lesson is resolving vectors into components. So again, we have our traditional xy coordinate axis plus x plus y. And let's say I have some vector we're going to call... Okay, let's try that again. I made a little mistake here. So I have some vector A. We're going to call that vector A in this direction. And let's say it is 30 degrees above the horizontal. And what I'd like you to do with this vector is resolve it into components. In other words, I want something called an A sub x and something called an A sub y. And we're going to use trigonometry to find this A sub x and this A sub y. Let's start with A sub x. If I took the side of the triangle, by the way, this is a right triangle. If I wanted to find A sub x, if I took the side of A sub x and I put it over the hypotenuse A, we would call that cosine theta or cosine of 30 degrees. If I multiplied both sides by the hypotenuse A, I would get A sub x is equal to A cosine of 30 degrees. Now what about AY? If I wanted to find A sub y, the side of A sub y over the hypotenuse A, just by trig definitions, is equal to sine theta, or in this case, sine of 30 degrees. If I multiplied A, or the hypotenuse, on both sides, I would get A sub y is equal to A sine of 30 degrees. Now, let's say I had a value for A. Let's say A was a value of 10 newtons. If A had a value of 10 newtons, then what is A sub x and what is A sub y? So let's go ahead and do that right now. A sub y, we'll just fill this in here first. We'll do that one first. That's going to be 10 newtons times sine of 30 degrees. Make sure your calculator is in degrees. And that gives me a value of 5 newtons. Plus 5 newtons, which means you could say north. And A sub x is going to be 10 newtons cosine of 30 degrees, and that's going to give me 8.66 newtons east, because it's positive. There you have it. That's resolving a vector into components. Now, I have a couple practice problems I want you to do. I want you to work on this, show your work on a piece of paper, and we're going to turn this in the next time we meet. So for practice, number 1, I will have a normal axis here, plus x, or 0 degrees, or east, plus y. Someone will apply a force of 1 Newton north, then they apply a force of 5 newtons east, and then they apply a force of 2 newtons north. What is the total resultant in this case, or what is the total force applied in this case? The magnitude and the direction. I'd like you to find both of those. The answer to this one is for magnitude 5.83 newtons, and the direction of this resultant vector is 31.0 degrees above the horizontal, or you could say 31.0 degrees north of east. Okay, so for number 2, we are going to again have our coordinate axes here. This is plus y plus x. We're going to go a little bit on the left side now, minus x and minus y, or north, south, east, west. And now I'm going to have a vector. We're going to call this vector B. It has an angle here of 25 degrees. We can read this 25 degrees north of west is one way of looking at that. Let's give B a value of 6 newtons. And what I would like you to do is to resolve this vector B into components. And here's your answer. Bx is equal to a negative 5.44 newtons. Notice that negative there. And B sub y is equal to 2.54 newtons. Good luck.